Hi, welcome. We've made it to the end of the Mosa Mack roller coaster energy project. Our final product for this project is going to be a lab followed by a presentation on our lab results. This video is designed to get you started on thinking about what you will do during the lab and some of the variables we will be testing. There will be a separate video with the lab instructions. So remember at the beginning of this project, you watched a video about Mosa Mack, and she was trying to solve a problem. Now, if you'd like, you can go back to November 30th in the agenda and watch this video, but take a moment and pause the video and recall what was Mosa Mack's problem at the beginning of the project. If you recall, her project or her problem was that the roller coaster couldn't make it to the end of the roller coaster ride. They tried all sorts of different things, like increasing the mass and trying to get the potential and kinetic energy to change so that it made it to the end of the ride. And what they ended up finding out was that mass certainly did affect it, but what really needed to happen is the potential energy needed to be increased. That way, the kinetic energy could take the roller coaster to the end. So they ended up finding that the first hill needed to be the biggest to make more potential energy. So we did a lot of lessons on potential and kinetic energy. You might recall math equations that we did with potential and kinetic energy. Take a moment and discuss what potential energy depends on and what kinetic energy depends on. And if you're watching this video, you can pause it and jot down on a scrap piece of paper the variables that affect both of these types of energy. All right, so we found in our lessons that potential energy depends on both mass and height. And we know that kinetic energy depends on mass and velocity. And Mosa Mack did try a lot of things. She did try to increase the mass in the roller coaster car, but it wasn't quite enough to speed the roller coaster up enough to make it to the end. So it was a combination of things, increasing the height of the first hill, which increased the potential energy, and then increasing the mass, which actually affects both potential and kinetic energy. So, although this project does not end with a roller coaster, it does end with a problem that is very similar to Mosa Mack's. You are going to help the Alleycats bowling team win a bowling tournament using your knowledge of kinetic and potential energy and the variables that affect them. So, what we need to do is recap what we know about potential, kinetic, energy, and work. And so, this is a document that your teacher may pass out to you and write down on the board. If you're doing this from home, you can certainly jot these things down on a separate piece of paper. One of the worksheets I will refer you to is our notes worksheet from the kinetic and potential energy math lesson. That was lesson 3. So you're going to define each of these things, write down any variables that affect it, and go over the units of measurement and any known equations. So this is something that you need to do on your own or with your teacher in class. If you need to, pause the video to take some notes now. So let's talk about the Alleycats Bowling League. So this is not your typical bowling alley. Think about a normal bowling alley. When you're trying to knock down pins, what are some variables that you can control to knock the most pins down? Take a moment and talk about that in class or think about it yourself. So in a normal bowling alley, you have a long alleyway with some pins at the end, and you're going to throw a bowling ball. So you may have discussed the speed at which you throw the bowling ball. Certainly you can throw it harder down the lane. And then there are usually different sizes of bowling balls. So you can pick up a heavier or a lighter. Now, really, you're only affecting the kinetic energy. You can change the mass or you can change the velocity. And if you are able to change both, then you have even more energy to apply to the pins, right? The Alleycats Bowling League is a little different. The Alleycats are in a bowling league where you can change the weight of the ball, but also the slope of the alley. So in other words, we are going to be able to roll a ball down an incline. Now, I will add this. I have seen in recent years at some bowling alleys, they have a little ramp for small children to put their ball on, and they can do that instead of throwing it down the lane. So it's kind of similar to that. You are going to have to design and conduct an investigation that can help them become the champions. In other words, how can they apply the most energy to the pins? Okay, and we want work to be done on the pins. We want the most potential energy, the most kinetic energy. So this is a different kind of bowling league. You can change the weight of the ball and the slope of the alley. All right, so we're going to use a few simple things in the lab, which is a separate video with instructions. You're going to have several different materials that are going to model on a much smaller scale this bowling league. Okay, we are going to use a marble to represent the bowling ball, and we'll have various sized marbles. We will have a ruler, which will serve as the track for the bowling alley, and we'll be able to place the ruler at different heights. And then we'll have an index card, which we will use to represent the pins, and we will be seeing how far we can push the index card to document how much work was done on it. So these are going to be your variables. In each part of the lab, you might be testing a different variable. For instance, you might be testing just different sized marbles for mass. In another part of the lab, you might be testing different inclines of the ruler, which is the ramp. And finally, you may choose to change two things at the same time. So a heavier marble with a much steeper incline. There are a lot of steps in this lab, and you will need to keep your variables separate so that you can report out to the Alleycats bowling team what you think is the best combination of variables to win the league. So we are using the scientific method to test the solution. The Alleycats will not take your recommendation for winning unless you have a professional presentation with data. This will include data tables and graphs that you collect throughout your investigation. You will first make a hypothesis. What do you think will be the best scenario for the Alleycats to win? You will identify all of the variables that are being tested. You will design the test, conduct the test and collect data, organize it into charts and graphs. And then for the hard part, you really need to look at as much data as you can and make an analysis and conclusion. You may be asked questions during the presentations and pressed on your findings to see if you really feel as though your findings are valid and good enough for the Alleycats to take your solution. So here are the variables that we're going to be focusing on. If you did the practice activities before Christmas break, these might look familiar. Take a moment in class or pause the video to go over these three types of variables to see how they fit into this presentation and in your lab that you're going to be doing. So we have quite a bit of time to conduct this experiment. This is not a race. In fact, I want you to take your time and make sure that you're collecting the best data possible. We are going to be doing most of this online, and so I'm not worried about lab packets coming and going from the classroom. We do have a few days to plan the investigation, a few more days to conduct the lab and to collect data, and a few additional days to create graphs. And since we're going to be doing this online, we will be using Google Sheets and creating graphs in Google Sheets, which can be copied and pasted at a later time into your presentation. We want to make sure that our graphs are labeled correctly and that they're formatted in a way that makes sense to the people that are looking at our graphs during the presentation. The conclusion is the most important part because we need to be using our data and explaining to the Alleycats why your data makes sense and why your data provides the best solution. It's also a good time to talk about errors, things that maybe didn't go so well, or places where you feel that the investigation should be repeated. And if you did repeat the investigation, you can talk about your differences in findings. So this video is meant to give you that overview of what we're going to be doing with the lab. If you need to watch it again, feel free. we will have a separate video with instructions for doing the lab and the lab worksheet.